Now, good day, good day, good day. Welcome back to our Puzzle 1 tutorial. Now, today too, we are coming to look at the continuation of trigonometry ratio. So pay attention carefully and then follow me as I'm leading you through. Now, at this particular point, I want to teach you the signs of the trigonometry ratios. Now, when I talk about trigonometry ratio, I'm talking about the sine, the cosine, the tangent, the cosec, the sec, and then the cotangent. Yes. Now, at this particular point, we are going to look at the behavior, how the trigonometry ratios behave in a circle or a quadrant. Yes. Now, first, I'm going to move fast, so pay attention and then follow me closely. Now, so the first, if I have a Cartesian coordinate, a Cartesian plane, I'm talking about the x and y plane. If I have x and y plane like this, now don't forget that this side is x and this side is what? Negative of the x. Now here is y and this point is what? Negative of what? Negative of y, right? So any point I'm going to get here, it means we're going to have xy because x is positive, y is positive. And any point I'm going to get here, the x is negative and the y is what? Positive. Now any point I'm going to get here, the x is positive and the y is what? Negative. And then any point in this particular point is what? X is negative and then the y2 is what? It's negative. Now that's the first thing you're supposed to know, right? So it means that whenever I have a particular point, coordinate, that coordinate will be in one of this particular place. Yes. Now don't forget that since we have a Cartesian plane like this, here is 19, here is 19, 19, 19. You get it? Yes. Now let me introduce a circle. Now if you have a circle like this, circle is 360 degrees, right? Yes. Now this particular circle, now if you want to consider the angle in the circle, if I want to consider the angle in a circle, then it means that this one is 360 divided by 4. 360 divided by 4 is 90 degrees. So here is 90, 90, 90. Now when we are reading angles, we read it in the anti-clockwise direction. Anti-clockwise direction. Anti-clockwise direction. The anti-clockwise direction gives you a positive angle. A positive angle. Now, the moment I read the angle in the clockwise direction becomes a negative angle. So the clockwise direction becomes a negative angle. Now, it means that when we are reading this particular angle, I have to start from here, being 0 degrees, up to this side being 90 degrees, this side being 180 degrees, here being 270 degrees, and then this side also being what? 360 degrees. I hope you are following. Yes. Now, at this particular point, don't forget that since this circle is divided into 4, we call each particular point a quadrant. So this side becomes the first quadrant, here becomes the second quadrant. Now this side becomes the third quadrant, and then here becomes the fourth quadrant. Now what are these? I'm talking about quadrants. Quadrants. So you have the first quadrant. Quadrant means 4. That is quarter. Yes. Now first quadrant, second quadrant, third quadrant, and fourth quadrant, because we read the angle in the anti-clockwise direction. The moment you read the angle in the clockwise direction, it becomes what? Negative. So the angle moves like this. The angle moves like this. Yes. Now we can move the angle above 360 degrees. Yes. Now look at it carefully. Now this particular point, we are going to look at how the sine and the cosine behave in all these particular quadrants. In the first quadrant, second quadrant, third quadrant, and then the fourth quadrant. Then you keep it in your head. We use that one as a reference whenever we are looking at any question or solving for particular angles. Now, let's dive into it. Now the board is supposed to have the cleaning, so you have to be anything you want to take note. You take your pen, shoe, you take note, your pen and everything. Yes, you take note. Anything you want to use, pencil, pen, or anything, crayon, you can use it. If you want to use color, you can use color. Now, let's look at this in very well. Now, at this particular point, let me locate a point in the first quadrant, then locate a point in the second quadrant, a point in the third quadrant, and another point in the what? In the fourth quadrant. Then we try to find the trigonometry ratios in those particular quadrants. Yes. Now, let me consider the first quadrant here. Let me consider the first quadrant. Now, what is the first quadrant? The first quadrant is the angle between 0 and 90 degrees. Now, the first quadrant is the angle between 0 and 90 degrees. So, third quadrant, the angle between 0 and what? Now, let's say the angle is theta. So, the angle theta is between 0 and what? 90 degrees. That is the first quadrant. Yes. Now, we can talk about the second quadrant. Now, don't forget that any angle between 0 and 90 degrees is also an acute angle. Acute angle. So, anytime the question talk of acute angle or angle between 0 and the 90 degrees or the first quadrant, they are still talking about the same particular place here. And you have to know the behavior of the trigonometry ratios in this particular quadrant. Now, let me talk about the second quadrant. The second quadrant. Now, the second quadrant is from 90 to 180. So, the angle is supposed to be between 90 and then 180 degrees. So, anytime the angle is between 90 and 180 degrees, it's also called obtuse angle. It's also called obtuse angle. So, anytime the question talks about obtuse angle or the second quadrant or the angle between 90 and 180 degrees, you need to consider that they are all the same. Now, don't forget that in the previous video, we talked about, we saw so many questions on the trigonometry ratio, but all the angles were between 0 and 90 degrees. You understand? Yes. Now I want to extend it so that I'm going to teach you how we can find the trigonometry ratios in all the quadrants. Yes, or how we can solve trigonometry ratio for all the angles. So follow me closely. Now in the third quadrant, now what's the third quadrant? Third quadrant is this one, the angle between 180 and then 270. So we have 180 degrees, the angle is between 180 degrees and then 270 degrees. Now the fourth quadrant here is also the angle between 270 degrees and then 360 degrees. Now don't forget that the 0 and 360 degrees, they are all at the same point, which means that when you find the trigonometry ratios of the 0 and the 360 degrees, we are going to get the same answer. Yes. Now at this particular point, I'm going to take it one by one. So let's look at it carefully. Now I'm going to use this one. Now let's consider the first quadrant. Now I'm going to write the answers here. Now the first one is the first quadrant. At the end of this one, you'll be able to know why we said the sign behaved like this in the first quadrant. Yes, in that order. Now, I'm going to talk about the first quadrant. Now, I have explained previously that the first quadrant is the same as the angle between 0 and then 90 degrees, or the acute angle, right? Now, let's move on. Now, let me consider a right angle triangle like this. So, as we said, the first quadrant will be any point at this particular point. At this particular point, the first quadrant will be here. So let me locate any point in the first quadrant. You get it? Now in the first quadrant, let me locate a point here. Now, whenever I locate a point here, it means the x is supposed to be positive and the y is supposed to be positive, right? Okay. Now, this particular point, what I'm going to do is that I'm going to resolve this one either along the x and then the y axis, right? But I'm going to focus on the x axis. We are going to resolve this one along the x axis. Now, so this straight line becomes the resultant. Then I'm going to resolve it along the x axis. So let's say the angle here is the angle theta. You get it? Okay. Now, don't forget that the point here is xy, and the xy means that x is positive and y is also positive. So it will be in the first quadrant. Now, at this point, don't forget that this side will be x and this side will be what? Y. This one forms a rectangle triangle. So here will be the length y, and then here will be the length what? X. Now, look at this very well. Now, so if I want to find the trig ratio, now look at the resultant. Now, let me use R to represent the resultant. Don't forget, no matter how the question is, we can find the resultant, right? This straight line. Now, since this one is a rectangle triangle, then here becomes the opposite, here becomes the adjacent, and then the R becomes the hypotenuse. So I'm using R to represent the hypotenuse. First quadrant. Now, let's find the sine. Let's find the sine. Now, a sine of the angle theta. Now, what is sine? You know, sine is opposite over hypotenuse, right? Now, if you look at this one, what is the opposite? The opposite will be y. You get it? The opposite will be y divided hypotenuse. Hypotenuse will be r. The hypotenuse is r. Now, let's consider the sine. Don't forget that in the first quadrant here, the x is positive and then the y is also positive. So which means that this y is positive. So we are going to end up getting a positive answer y over r, which is what? Positive. We already determined the signs, don't forget. Now the second one, let's talk about cosine. The cosine is adjacent over hypotenuse. And what is the adjacent here? Adjacent here is the x. Hypotenuse is r. Now don't forget that on the x-axis here, the x is positive. So it means the x here is positive. Don't pay attention to the laugh. Now, look at this. We are getting a positive answer because here is positive, here is r. Don't forget that r is also a length. So that one, no matter how the thing is, we are going to get a positive answer. Whether this one is negative or this one is positive, we are going to still get a positive answer for the r. That is the resultant or the hypotenuse. So this one is also giving us a positive answer. Now, let's come to the tan theta. Now, what is tan? Tan is opposite over adjacent. Now, what's the opposite here? The opposite here is y. Of course, it is y. The adjacent is x. Don't forget that we are talking about the point xy. So the x is positive, the y is also positive. So x being positive, y being positive, it means that we're going to get the same thing, y over x, which is also positive. Now, what are we seeing here? Now, what we are seeing here is that the sine is positive, the cosine is positive, and then the tan is positive. Don't forget, we are only looking at the signs, whether negative or positive. So this one, with this one, we can make conclusion. We can make conclusion that in the first quadrant, all trig ratios are positive. All trig ratios are positive. All trig ratios are what? Positive. I hope you are following. Okay, because the sine is giving positive, the cosine is giving positive, the tan is also giving positive. Now let me extend this one. Don't forget that we can also talk about the sec of theta, and then sec is 1 over cos, right? Now since the cos is positive, then it means that the sec will also give us positive. Now cosec of angle theta, don't forget that cosec is 1 over sine. And since the sine is given as positive, it means cosec also given as positive in the same first quadrant. Now, what is cot? Cotangent. Cotangent is 1 over tan theta or cos theta over sine theta. Now, since the tan theta is positive, then it means the cot will also give us positive. So if I want to continue with this one, this is what I'm going to get. Don't forget that the answer to the sine also affects the cosine, the answer to the cosine affects the sec, and the answer to the tangent also affects the what? The cot. Because the answer, the sign we are going to get for the sine, it will be the same as the cosine. Answer you're going to get for the cosine, you're going to give it the same as the sec. Then the sign we are going to get for the tan will also be the same as the cot or the cotangent. Now let's move on to the second quadrant. Now two, I'm talking about the second quadrant. Now don't forget that when we talk about the second quadrant, we are talking about the angle between 90 and then 208 and 180. Now don't forget that this one is the second quadrant. Second quadrant, here is 90, here is 180 degrees. The second quadrant the same as the obtuse angle. Now, so in the second quadrant, let's look at the behavior. Now, don't forget that second quadrant, the x here is negative, and then the y here is what? Positive. So if I locate any point in the second quadrant, the x is supposed to be negative and the y is supposed to be positive. Now let me use this one to form a rectangle triangle. So it seems that I need to resolve this one along the x and y axis, but we are going to resolve them, all of them along the x axis. So what will be the resultant? This one will be the resultant straight here up to the origin. Now let me resolve this one along the x-axis. So I'm going to get the angle along the x-axis. Let's say the angle here is theta. You get it? Then don't forget that this part is x, and then this side will be what? Y. Now let's use the resultant or the hypotenuse to be r. Now this side will form an angle of 90 degrees because they are perpendicular to each other. You understand? Yes. Now don't forget that why are we moving in the second quadrant? We are moving in the second quadrant because the s is negative, the y is what? Positive. But don't forget that since I am talking about a rectangle triangle, the rectangle triangle distance from here to here is supposed to be x positive. We are not supposed to get negative. Yes. Because we don't have negative side or negative length. Now, at this particular point, let's find the sine of the angle theta. Don't forget, sine is opposite over hypotenuse. Now, what is the opposite? The opposite is y. Over hypotenuse, which is r. Now, don't forget that the hypotenuse is always positive because the hypotenuse square is equal to this one square and this one square. So no matter how the x and y will be, the hypotenuse will always be positive. Now, let's check the y. At this point, the y is positive. The y is positive. So the answer will still give us y over r. And then we are getting positive for the sine. So in the second quadrant, we are getting positive for sine. Follow me closely. I'm going to teach you this one. I'm breaking it down how we had what we have here. So let's look at it. Now let's go to the cosine. Cosine. Now cos is adjacent over hypotenuse. Now what is adjacent? Adjacent to this one is the x. The hypotenuse is the r. Now look at something here. On the x, look at the point x. The x is negative, so I need to bring my negative here. So what is negative x over r? To give us negative x over what? R. Now the answer is given as negative. The sign is given as negative. It means that in the second quadrant, we are getting the cos to be what? Negative, by the sign to be positive. Now let's check the tan. Tan of the angle theta. Tan is opposite of adjacent. Now, what is the opposite? The opposite is y. And what is the adjacent? The adjacent is x. Now, let's look at something here. At this particular point, the y is positive. And the x is what? Negative. So, what is positive or negative? Positive or negative will give us what? Negative y over x. So, we are getting negative for the sign. Check if a model display scan. For the sign. Now, at this particular point, now, at this particular, what are we getting here? You can see that the sign here is positive in the second quadrant, the cos is negative, and then the tan is what? Also negative. So we can conclude that at this particular second quadrant, only sign is positive. Only sign is positive. Only sign is positive. Only sign is what? Positive. Because the sign is given as positive, the cosine is negative, the tan is negative. So we are getting only sign to be what? Positive. So whenever you have a question in this particular part, you have to know that sine of any angle between 90 and 180 will give us positive. But when you have sine of any angle between 90 and 180, the cosine will give us negative. The tangent will also give us negative. I hope you have followed. Now let's move on to the third quadrant. Now let me continue from here. Third quadrant, 3. Third quadrant. Because today I want to relax and prove the thing for you. Now, third quadrant. Now, don't forget that we can also find the sec, the cosine, and then the sec, the cosec, and then the cotangent. Now, since the tan is given as negative, the cotangent will also give us negative. Now, since the cosine is given as negative, then it means the secant will also give us negative. Now, since the sine is given as positive, then it means the cosec will also give us what? Positive. Yes, because the cosec is 1 over sine. So if the sine is positive, probably it also gives us what? Positive. You get it? Yes. Now let's move on. Now, anything in the third quadrant. Now, so let me locate a point in the third quadrant. Don't forget the third quadrant is here. Third quadrant is any angle between 180 degrees and then 270 degrees. Now, let me locate a point here. Don't forget that any point here contains the x component to be negative and then the y component to also be negative, because the s is negative here, the y is negative here, right? Yes. Follow me closely. S negative, y is negative. Now, so let me indicate the resultant. Now, this is the resultant. Let me resolve it along the x-axis. Now, this is the angle theta. Don't forget that I'm resolving all of them along the x-axis. Theta. Now, the resultant here becomes a r. Don't forget that here is x. Here will be 90 degrees. This side will be x. We don't write negative x because we don't have, this is a right angle triangle, and we don't have a negative side or negative length. Now, this side will be y. This side will be y. Now, so let's find the sine of this one. Sine of theta. We know sine is opposite over hypotenuse. Where is the opposite? The opposite is y. The hypotenuse is r. Now, don't forget that the y is negative. So, we're going to get negative here. So, what are we getting? Negative y over r is the same as negative y over r, which is giving us what? A negative answer. So, the third quadrant, you are getting the sine to be negative. Now, let's go to cosine of theta. Now, cosine is adjacent over hypotenuse. Where is the adjacent? Adjacent is the x. The hypotenuse is the r. Now, don't forget that at this particular point, the x is negative. So, let me negate this one. So, what are you going to get? Negative x over r. And then we are getting a negative answer for the cosine. So the cosine is negative. Also, it means that in the third quadrant, we are getting sine to be negative, cosine to be what? Negative. I hope you are following clearly. Now, let's go to the tan of the angle theta. What is tan? Tan is opposite over adjacent. Where is the opposite? The opposite is y. The adjacent is x. Now, don't forget that the y is negative here, and then the x is also negative. So what is going to happen to this one? Negative will cancel negative. So we're going to get y over x, which is positive. Now, what are we getting here? We are getting the tan to be positive. The sine and the cosine, they are all negative. Now, it means that anytime you get an angle between 180 and then 270, only the tan theta will give us positive. Now, since the tan theta is giving us positive, it means that the cotangent will also give us positive. Now, since the cos is giving us what? Negative, it means that the secant or the sec will also give us negative. Now, since the sine is giving us what? Negative, it means that the cosec will also give us negative. So at this point, we can conclude that only tangent is negative, is positive. Now, let's go to the fourth one. Let's go to the fourth one. So at this particular point, any angle in the fourth quadrant, any angle in the fourth quadrant. Now the fourth quadrant is here. The angle is between 270 and then 360 degrees. In the fourth quadrant, you can see that the x here is positive and the y here is what? Is negative. Right? Y is negative, x is positive. Now I'm going to consider this particular point. Let's find the resultant first. You get it? Then let's resolve it along the y, along the x-axis. So resolve along the x-axis. We're going to have our 90 degrees here. Our 90 degrees. Now let me consider the angle along the x-axis to be theta. Then the angle here, the length here will be y. The length here will be what? X. Now let me consider the hypotenuse to be r. Yes. Don't forget they are all positive because we don't have a negative length here. The moment you draw it and very negative, it means we don't know what we are talking about because this one is a rectangle triangle. Now, fourth quadrant. Fourth quadrant. That is an angle between what? 270 and 360. Now let's check sine. Sine theta. Sine theta. What is sine? Sine is opposite over hypotenuse. Now what's the opposite? The opposite here is y. The hypotenuse is r. Now don't forget that at that particular point the y is negative. So I'm going to write negative here, which means we are going to get negative y over r. So which means we are getting negative for the sine. Now let's move on to the cosine of the angle theta. What is cos? Cos is adjacent over hypotenuse. Now what is adjacent? Adjacent is x. Hypotenuse is r. So we are going to get the x. At this point, the s is positive. So I'm going to maintain the s positive. Now, so x over y is the same as s over r, the same as the same x over r. We are getting positive for the cosine. Now, let's come to the tangent of the angle theta. Now, tan is what? Opposite over adjacent. The opposite here is y. The adjacent is x. Now, don't forget that the y component is negative. So I'm going to negate this one. So we are getting negative y over x, which is same as negative y over x. So the whole thing will give us one negative. Now, what conclusion can you make here? It means that anytime you have an angle between 270 and then 360, the sine of any angle between 270 and 360 will going to give us negative answer. The cosine will give us positive answer. And the tangent will give us negative answer. So we can conclude that only cosine is positive. Only cosine is positive in the fourth quadrant. So let's look at it. Let's arrange it here. Now, so it means that in our Cartesian plane, where this side is 0, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. It means that at this particular point, all the trig ratios, all of them, they are all positive. All the trig ratios are positive in the first quadrant. All the trig ratios are positive. All. Now, so all, I'm using all. All are positive. That is A. All are positive. It means the sign is positive. It means the sign is positive. Cosine is positive. Tangent is also positive. Now, in the second quadrant, which one was positive? In the second quadrant, only sign is positive. So we're going to have the sign is positive. So x is positive. The tan is negative. The cosine is what? Negative. Now, in the third quadrant, only tangent is positive. So third quadrant, we have tan. Tangent is positive. So t is positive. Tangent is positive. Now, when we come to the fourth quadrant, we had the cosine to be positive. So we're going to have the cosine here. Cosine is positive. Let me write this one in 4. Tangent is positive. Now, you can keep this thing in your head. You can keep this one in your head. This one is C-A-S-T. C-A-S-T. Now, so if you want to remember the signs of the trigonometry ratio along the x and y plane or the Cartesian plane, you can use cast to remember. You can use something called the cast. The cast means that we start from here, only cos is positive in the fourth quadrant. All of them are positive in the first quadrant. The S, only sign is positive in the second quadrant. And then only tan is positive in the third quadrant. But this is what I want you to know. Yes, in the next video or the subsequent video, I am going to make good use of this particular thing, and I don't want to spend more time. So let's move on into the next video. Then we dive into it. Let's solve more questions on this particular area using the cast. Now, see you in the next video. Bye.